2.3.1, let's review 2.2.1 first, where we're identifying some characteristics for this quadratic function. So make sure you try this on your own before continuing the video, so pause, give it a try. Okay. All right, so this is a quadratic function. Since the highest exponent is a 2, when we're finding our x-intercepts, remember, to find those x-intercepts, we should factor. So when we're factoring here, we set it equal to 0 and look for numbers that multiply to c and add to b. Multiply to 12 and add to 8. Those numbers are 6 and 2. To get our x-intercepts, we set those factors equal to 0 and solve for x. So we get x equals -6 and x equals -2. The y-intercept is just the c value, which in this case is 12. To find the line of symmetry, or axis of symmetry, we have that formula, x equals -b over 2a. In this case, b is 8, so we have -8 over 2 times 1. -8 over 2 equals -4. So x equals -4. Remember, the line of symmetry also tells us the vertex, which in this case, or at least the x value of the vertex. To get the y value, we have to plug the x value into the original equation. So we'll have y equals -4 squared, 8 times -4, plus 12. -4 squared is 16. 8 times -4 is -32. 16 minus 32 is -16. Plus 12 is -4, so we get -4 there as well. Since our a value is positive, our directionality will be upwards, or it opens up. Since our directionality is up, our vertex would be a min. Factored form is right up here. It's just, we write it as our factors. So y equals x plus 6 times x plus 2. Vertex form, remember, is y equals a times x minus h squared plus k, where hk is our vertex. And a is just 1 here because it's 1x squared, so we have y equals x minus h, so minus -4. Subtracting a negative is the same as addition. Plus -4 or -4. There we go. Okay. All right, on to this new stuff here. So, the following graph shows the flight of a basketball measured in seconds in the air and feet off the ground. Answer the following questions. What is the starting height of the basketball? How long does it take for the basketball to reach its max height? And what is the max height of the basketball? And how long does it take for the basketball to hit the ground? Okay, so let's think about this. So it says the flight is measured in seconds in the air and feet off the ground. So time would be our x value. So there's seconds in the air. Feet off the ground would be our y. So we have this flight of a basketball. So when time is at 0, it's at 2 feet in the air. The basketball is traveling. Its vertex here, this would be the highest point. It's traveling over time. It hits the ground here at 3. So the starting height we could think of as the y-intercept, which would be 2. So the starting height here is the y-intercept. Next it says, how long does it take the basketball to reach the maximum height? So the maximum height would be this point here. So let's think about this maximum height. So that looks like about 2.5. So the maximum height, so that's number 3, is about 2.5 feet. The time it takes to get there would be the time at that height, which would be 1. So 1 second. And how long does it take for the basketball to hit the ground? Well, the height here is our y-axis. Hitting the ground would be at 0. It hits the ground here after 3 seconds. Okay. Not too bad. Now let's look at it in terms of a function. So here we go. The Hulk throws a starburst off a cliff. The time measured in seconds, it is in the air, and the height off the ground measured in feet can be modeled by the quadratic function f of t equals negative 2t squared plus 800t plus 1400. Answer the following 3 questions. Remember, we're just thinking as a function of time, so think about t as like your x value, f of t is your y. So what is the starting height of the starburst? So if we think about the last problem, the starting height, remember, was just the y-intercept, which we know the y-intercept is the c value. So it would be 1,400 feet. What is the maximum height of the starburst, and how long does it take to get there? So if we're thinking about this parabola, remember the maximum height means we're finding the vertex. So to find the vertex here, let's think about what we need. So that vertex, remember, we can find the x value from the axis of symmetry. So let's put my work here. So for the vertex, to get the x value, we need to use that axis of symmetry. X equals negative b over 2a. So our b value here is 800, so we have negative 800 over 2 times our a value of negative 2. So negative 800 over 2 times negative 2 is negative 4. Negative 800 divided by negative 4 is 200. So the x value would be 200. To get the y value, we have to plug that into the initial equation. So up here, plug in 200 for t. So we'll have negative 2 times 200 squared plus 800 times 200 plus 1,400. And that's something then we need to go ahead and simplify. I'm looking for my calculator, but having a hard time finding it. So we'll do this the old-fashioned way. So starting with this 200 squared. 200 squared is the same thing as 200 times 200. So 0 times 0, so on and so on, 2 times 0. So we get 40,000. So negative 2 times 40,000 plus 800 times 200. 1, 2, 16. 160,000 plus 1,400. Okay. So that'll be negative 80,000 plus 160,000 plus 1,400. These will add to 80K plus 1,400. So that'll leave us with 81,400 feet. So that's our vertex, an x value of 200, a y value of 81,400. So if we're thinking about this, our graph says time measured in seconds, height off the ground measured in feet. So time in seconds will be our x, height off the ground measured in feet will be our y. So if it's saying, what's the maximum height and how long does it take to get there? So our maximum height would be this y value. So 81,400 feet. Our time it took to get there was 200 seconds. Okay. Next it says how long does it take to hit the ground? So if we're looking for when it hits the ground, that's when our height would be at 0. So what we're looking for is the x-intercept. So for us to find the x-intercept, we have a few options. So factoring is an option. But as we look at this problem, I notice my a value is not 1. So the quadratic formula might be the better move. So let's put my work down here to find our x-intercepts. So we have x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is our quadratic formula. So let's plug in a, b, and c. So b is 800. So we have 800 squared minus 4 times negative 2 times 1400 all over 2 times negative 2. Okay? And then we simplify. So we got some big numbers here. Okay. Let me get my computer. All right, this is not one that I want to do by hand. So we'll start with that 800 squared. So 800 squared, or 800 times 800. 640,000, big number. And then we have negative 4 times negative 2 is 8. 8 times 1400 is 11,200. So this is going to simplify to 11,200. So I'm just going to put that over here. Let me see. Yeah, we can see. Okay. So 64K, 640K, wow, plus 11,200 all over 2 times negative 2 is negative 4. So let's add these together and take the square root. So I'm running out of space. I'm going to have to shift over this way. So here's where we're at. We're at negative 800 plus or minus the square root, 64,000 plus 11,200 all over negative 4. So let's add these together. So when we're adding those together, let's see, we would get square root of 65,1, 200 all over negative 4. So let's see what the square root of that is. So 651, 2, 0, 0, square root of that. Okay. We get 806.97. I'll round to 2 places over negative 4. Let's divide both by negative 4. So negative 800 divided by negative 4 is 200. 806 and so on divided by negative 4 is a negative 201.74. So let's figure out what these would be. So we would have 200 plus negative 201.74, which would equal negative 1.74, and 200 minus negative 201.74, which we're subtracting a negative, so that's the same as adding, which will give us 401.74. Okay. So we have 2 solutions. So our x-intercept is either negative 1.74 or 401.74. So let's think about what makes sense. So it's asking us how long does it take to hit the ground? Does it make sense that it would take negative 1.74 seconds to hit the ground? Not really. But it would make sense that it takes 401.74 seconds to do so. Okay. Last thing we'll do is let's just graph this. So we have a few key points. So we have that vertex at 281,000. So let's make sure we're fitting here. So let's go by, we'll go by 100s on the x, and we need to make sure to fit 81K. So let's go by 20,000 a piece. So I'm going to put K's here because that's a little bit easier for me. So our vertex is at 281,400. So that's just above 80,000. Our y-intercept we found was at 1,400 feet, so not very high. And we found our x-intercept was at 401 seconds, so right here. So this would be our parabola. And there we have it.